Hello, welcome to this video on exercise 3. This is a rather large system of equations. It's 5 equations, and if you look carefully, there are also 5 variables here. Well, these are x1, x2, x3, y1 and y2. The exact letters are of course not important. It could also have been x1, x2, x3, x4, x5, but now we have chosen not to do x4 and x5, but y1 and y2. It doesn't really matter. Now we have to choose an order. Because all the coefficients are in front of the variables, so we don't have to do that. It's already taken care of, but of course we need an order. Well, the most logical order that I can think of is this one: x1, x2, x3, y1, y2. Let's put all the equations in this order. Okay, the first one. Then we have to search for an x1, and that is over here. So then we write down minus 2 times x1. The next one is x2. It's over here. So that's plus 5 times x2. And then minus 12 times x3. Now we have to search for y1. That is over here. So we have plus 3y1, and the last one is plus 3 times y2. And that should be equal to minus 1, and the minus 1 should be on the right hand side because it is completely known. Next one. 3 times x1 minus 2 times x2 plus 3 times x3 minus 12 times y1 plus 5 times y2. Well, there is no constant here, so it ends with a 0. Next one. 3.5 times x1. That's this one. Minus 10 times x2 minus 2 times x3 minus 2 times y1 plus 6 times y2. And here we have minus 20 on the left hand side, but that should be on the right hand side, and the minus becomes plus, so we have 20 on the right hand side. Minus 8 times x1 minus 2 times x2 minus 5 times x3 plus 3 times y1 minus 12 times y2, and the 13 stays on the right hand side. Last equation, there we have, this is the first one, 5 times x1. Okay, x2 is not present, so what we do is plus 0 times x2. x3 has minus 12 as a coefficient, plus 3 times y1 minus 4 times y2 equals, well, this number 12 goes to the other side, so that's minus 12. So here they are in the right order, and now we have to construct a matrix. Matrix A. Well, if you look with me, then you will see that we have to put a -2 over here. 5 minus 12, 3, 3, 3 minus 2, 3 minus 12, 5, 3.5 minus 10 minus 2 minus 2, 6, minus 8 minus 2 minus 5, 3 minus 12. So 5 for the last equation, 5, 0 minus 12, 3 minus 4. And we end with a large square bracket. Okay, so that's the A matrix. The B matrix will be -1, 0, 20, 13, minus 12. And that is just the right-hand sides of the 5 equations. And now the way to solve this is exactly the same as in the former examples. We say to MATLAB S equals A backslash B, and the solution will be in S. So that's what I'm going to do now. So that is -2, 5. A equals -2, 5. -2, 5, -12, 3, 3. -12, 3, 3. And with a semicolon. And in this case, MATLAB does not protest if you put an enter now, and you can just go on. This is not as, with all statements in MATLAB. It's just when inputting a variable. 3 minus 2, 3. 3 minus 2, 3. -12, 5. -12, 5. Semicolon, enter. 3.5 minus 10. 3.5 minus 10. -2, -2, 6. -2, -2, 6. -8, -2, -5. -8, -2, -5. 3 minus 12. 3 minus 12. And the last row will be 5, 0, minus 12. 5, 0, minus 12. And 3 minus 4. Now we put the square bracket, no semicolon. The last row, that is not necessary. It is even not allowed. And then we put a semicolon to end the statement, and we put an enter. This is the matrix A. Now we put in matrix B between square brackets. -1, 0, 20. -1, 0, 20. 13 minus 12. 13 minus 12. So beware of the semicolons after each row, and because a row only consists of one column in this case, you put a semicolon immediately after the numbers that you input. Okay, enter, and here is our B matrix. Now, then we say S, which will contain the solution, equals A backslash B. This code is always the same. Enter. And this is the solution. Well, it very well may be. I'm not going to check it. I'm going to completely rely on MATLAB. So minus 2.2 is the value for x1, minus 2.2, also 2.2, but it's a little bit different, is x2, x3 is minus 0.2, and these two are for the y variables. So this is how it's done in MATLAB.